This video is based on certain algorithm design techniques, for example, divide and conquer, greedy method, dynamic programming, backtracking, branch and bound. In this video, we will discuss greedy method. So first we have divide and conquer. As we know, many useful algorithms are recursive in structure, and to solve a given problem, they call themselves recursively, but need more time to deal with closely related subproblems. Here, three main steps are followed by a divide and conquer technique. First, divide the problem into a number of subproblems. After that, conquer the subproblem by solving them recursively, and in the end, combine the solution to the subproblems into the solution for the original problem. For example, merge sort algorithm follow divide and conquer technique. Next is greedy method. Greedy method is the most straight design technique that can be applied to a wide variety of problems. Here we require to obtain a subset that satisfies some constraints, and if any subset satisfies these constraints is known as feasible solution. Our goal is here to find a feasible solution that either maximize or minimize the given objective function. A feasible solution either maximize or minimize the objective function, then it is known as optimal solution. You can see the difference between optimal solution and feasible solution. If any subset satisfies certain constraints, then it is known as feasible solution, and if a feasible solution that either maximize or minimize the given objective function, then it is known as optimal solution. Now let's try to understand greedy method using an example, that is knapsack problem. Suppose we are given n objects. Here n is used to represent objects, and we have a knapsack, or you can say bag. Object I has a weight wi, you can see here, and we have knapsack capacity that is denoted by m, and you can see the constraint here. If this constraint is satisfied, then object I is placed into the knapsack, and then a profit of pi xi is earned. So first we will satisfy this constraint. Once this constraint is satisfied, after that we can place the object inside knapsack, and then we will calculate the profit earned. So our objective is here to obtain filling of knapsack and gain the maximum profit. Here you can see our objective is to get maximum profit. So you can see here, maximize the objective function subject to, you can see we have certain constraints to satisfy. Now let's try to understand this with an example. Consider the following instance for the knapsack problem. We have three objects, so value for n is 3. Knapsack capacity is represented by m, so m is here 20, that is the knapsack capacity, and we have three objects and knapsack capacity is 20, and object weights you can see, and the profit you can see here. Now we need to satisfy this constraint. Once this constraint is satisfied, after that we can place the object inside the knapsack, and then we will calculate the profit. As you can see here, we have 4 sets and they all satisfy this constraint. Now this constraint is satisfied. Now we can place the objects inside. So one by one we will calculate the values for the each set. First we will calculate values for the first set, this one. So here this constraint is satisfied. Now we want to place the object inside the knapsack, and knapsack capacity is 20. Now we will calculate the value, that is the weight for the each object. So for this set you can see, put all the values here. First object x1, x2, x3, and we have weight for x1, x2, x3, and we got 16.5. Now we will check the knapsack capacity. As you can see, this value is less than 20, so this constraint is satisfied. Now we can calculate the profit. So you can see all the values here, put the values together and we got 24.25. Like that, one by one for each set we will calculate the weight and profit, and you can see we got all the values here. Here you can see, as we know that if any set satisfies the following constraint, then it is known as feasible solution. And you can see we have certain feasible solution and then we have profit. Now we need to find out the maximum profit. Here, out of 4 feasible solution, you can see this solution has maximum profit. So we will consider this optimal solution. So we need to find out the optimal solution for this problem, and here the optimal solution is this one. So our aim is here to find out the optimal solution. Optimal solution means feasible solution that either maximize or minimize the objective function, and in this problem we want to gain maximum profit. So this solution, as you can see here, out of 4 feasible solution, this feasible solution gain maximum profit. So it is considered as optimal solution. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.